So there's a couple other cool things that we can do with the pH equals negative log H3O plus. One thing that we can do is go the other way around. So let's say the pH equation up here, this pH equals negative log of H3O plus, this is the equation that we would use when we know H3O plus and we want to calculate pH. But what if we wanted to go the other way around? To calculate the H3O plus from the pH, like if we knew the pH and we needed to know H3O plus. In that situation, we use the antilog. So the H3O plus concentration is equal to 10 raised to the power of the negative pH. And we can do the same thing with OH minus. We haven't talked about pOH much yet, but we're going to put that in here, and we are going to talk about it. If we wanted to calculate the OH minus concentration, that would come from 10 to the negative pOH. So another cool equation that we can use for any solution My screen is spazzing out. For any solution that we have, oh my gosh, we can say that the pH of that solution plus the pH of the same solution. So we're calculating the pH of the solution as well as calculating the pH of the same solution. They are always equal to 14. And this is a really helpful equation. So this equation we're going to use a lot. And we're also going to use the pOH equations a lot as well. Even though we're not using them yet, we will. We'll use them quite a bit. Let's talk about this cool equation though. pH plus pOH equals 14. Let me show you where that comes from because this is fantastic. So one of the things in the last set of videos that you looked at was the KW equation. KW equals H3O plus times OH minus, the equilibrium expression for water. And I told you that that was equal to 1 times 10 to the minus 14. Now, bear with me. We can take the log of H3O plus times the log of H3O plus times OH minus and make that equal to the log of 1 times 10 to the minus 14. So all we're doing here is taking the log of both sides of the equation. And you might be asking, why on earth would we do that? Just hold on and you'll see why. So now we're going to do some math here. One of the properties of logs is if you have a log of two numbers like a times b, that can be simplified as, or expressed differently as the log of a plus the log of b. That's just a property of logs. So we can go log of H3O plus the log of OH minus. Again, that's just a property of logs. And that is going to be equal to, over here on the right side, we can actually do this on the calculator. Type in log of 1 times 10 to the minus 14, and the answer is minus 14. I'm going to move, I don't like the negative sign, so I'm going to move the left side of the equation to the right, and the right side of the equation to the left. So I'm going to get 14 equals negative log H3O plus minus log of OH minus. And all that I did there, because I don't like the negative sign of the 14, all that I did there was take the left side of the equation and move it over to the right, and I took the right side of the equation and I moved it over to the left. And then now look at what we've got. 14 is equal to negative log of H3O plus, which is the pH. and the negative log of OH minus, which is the pOH. Isn't that cool? So that's an equation that we can use. If we know pH, we can calculate pOH and vice versa. Let's try a couple of calculations. What is the pH of blood with an H3O plus concentration of 5 times 10 to the minus 8 molar? This is a really simple calculation. To solve this problem, we're just going to use our pH equation. pH equals negative log of H3O plus. We are going to plug in the H3O plus concentration given to us, 5 times 10 to the minus 8. And you're going to crunch those numbers on your calculator, and you're going to get something that is about 7, approximately 7. Here's another calculation. This one's a little trickier. That blood one was pretty easy. What is the OH minus concentration of tomato juice with a pH of 4.2? Ooh. What is the OH minus concentration? Let's look at the equations that we have available to us that use OH minus. If we're looking at using OH minus, we've got this equation right here. It's got OH minus in it. And we also have this equation up here, has OH minus in it. Now this equation up here, we really don't want to use it in this form because the OH minus, which is what we're trying to solve for, is stuck in this log function. This equation down here, this is a good one to use because we have OH minus on the left side of the equation. That's what we're trying to figure out. So let's start with that equation. We want to use OH minus equals 10 to the negative pOH. So to figure out OH minus, we need to know the pOH of the solution and plug it into this equation. So how are we going to figure out the pOH? To do that, we've got this cool equation right here that we can use. pH equals pH plus pOH equals 14. We know that the pH is 4.2, and so we can use this equation to solve for pOH. The pOH is 9.8. And now that we know the pOH, we can go back over to our OH minus equation and we can plug that in. 10 to the negative, don't forget the negative, 9.8. Now for me, I'm happy with that answer. The OH minus concentration is 10 to the negative 9.8. But Alex doesn't like that. It wants you to actually type this into the calculator and hit enter and see what you get when you do the math on 10 to the negative 9.8. And you're going to get 1.58 times 10 to the negative 10 molar.